what I will do is I will go into I'll pull them apart. Oh. Let them, I'll pull them apart. So this is being displaced by x1, the same reduced mass what we did, the similar condition here. And let this be x2. What is the total elongation of spring? Will be kx, not kx1, kx2. I think everyone knows this. There's a center C2, there's a center C1. Let's come for the friction. The friction here, let it be rolling friction will act. As a teacher, I helped up to this section. I know what to do after this. Friction will be same or different. It must be different, no? Rolling friction. It depends upon the moment of inertia also. So this will accelerate center of mass. So this will be A2. This will be alpha 2. This will be alpha 1. What is the elongation? So that x should be equal to x1 plus x2. We know total elongation. And according to center of mass concept, m1 x1 equal to m2 x2. Is that justified? Okay, let's see that kx. I'll proceed like this. Kx minus f1 equal to mass, same mass, both are having same mass. M A1. Then at the same time, F1 R is equal to IC1 alpha 1. Then for no slipping, A1 equal to R alpha 1. So let me substitute here. This is the A is what? A is a hollow sphere. No, A is a uniform hollow sphere. So 2 by 3 mr square into alpha 1. Alpha 1, I can write it as A1 by R. Let me substitute this here. So this will become kx minus 2m a1 by 3 equal to ma1. Or this will be kx equal to but is it SHM? What is the displacement of what is the displacement of center of mass C1 is x1? No, not x. So I should replace x in terms of x1. I'll take help of this mathematics here. So here x2 I'll replace it as m1 x1 by m2. So x1 x has to be replaced. So where x is equal to m1 plus m2 by m2 into x1. This is both are same masses, no? Okay, this will become 2x1. So x equal to 2x1, I'll write it directly. So a equal to 6k by phi m into x1. The negative sign, you can bring it from the beginning. Okay, again, you'll get confused if I write any of the negative signs. So let me just compare. Later or in the end, you can write negative sign. That acceleration a1 is opposite to displacement because the center of mass is shifted towards left, or the spring force acting towards right. They'll be opposite. Here, if you want, you can bring sign. So let me not complicate it by introducing sign in the end. It is understood from the diagram. So what is the time period now? So 2 pi. Moment of inertia 2 by 3 only, no? It is? Yeah. Okay, now you can ask questions like how you wrote some. What is the basis for this? Is it justified? Net force on the system should be zero, no? Look at this F1 and F2. B is uniform, A is a uniform hollow sphere, and B is a uniform solid sphere. And B can roll without sliding on the floor. They're also tied centrally to a light spring. Okay, this is about spring is x naught. Find the frequency of oscillation of the spheres. Okay, what actually the thing is M1 equal to M2, no? Okay, we have substituted all this one. Look at the answer. We ended up something 5m by 6k. All becomes 6k by 5m. Anybody, can you point out anywhere we have to? Net work done by this should be zero. Rolling friction, no, net work done by this will be zero. Then what all form it will have? It will have the energy in the form of elastic potential of spring, translational kinetic energy, and rotational kinetic energy. Hide this for uniform solid sphere. What I did, I got this expression. We ended up here. Then if I do this for solid sphere, yes, again you can work out kx minus f2 equal to ma2, then f into. Okay, let me try whether we are right or wrong. I will post these things. Both should have same time period. There's a cross checker. Okay, let me do this for the other part. So this will be kx minus f2 should be equal to ma2. And again, same thing, f2 into r should be equal to ic2 alpha 2 and a2 equal to r alpha 2. So this should be f2 into r 2 by 5 mr square ac by r. So f is equal to 2 by 5 mac f2. Let me substitute that here. A2 it is, sorry. Kx minus 2 by 5 ma2 equal to ma2. Kx equal to 7 by 5 ma2. Again, what is x? X should be in terms of x2 has to be brought. X equal to 2x1. Substitute that one. X1 should be replaced, no? So therefore, this will be x is equal to x1 is x by 2 plus x2. So x2 equal to x by 2. X equal to 2x2, I'll write it. A2. So this will be 10K by 7M X2. Look at the issue. There is some very big issue. What is right? What is wrong? Both should have been same time period, no? So the time periods are different. So some problem is there with the way what we are doing this particular problem. If masses are same, if M1 and M2, okay, let it be this, and let it be same one solid sphere, things should have been different. It can be like this also. If both were uniform solid sphere or both were hollow sphere, what we are discussing, this will be applicable. Huh? The way what we are thinking. This is solid sphere, this is thing. So the rolling frictions will be different, but the net work done by them. That's what. See, like a rolling frictions are different here. So F1 is not equal to F2. So can you write this one? So no longer what happened, we can write this particular thing. In fact, center of mass itself will accelerate. So we are discussing this problem about a point where the center of mass is accelerating. What we earlier, we had a problem where the center of mass was at rest. That the question is like this. Huh? So here, because this is a if both were uniforms, hollow sphere, okay, I would have proceeded in the same way. Tomorrow we'll discuss this one. I think don't have time. Okay, I'll just change this. If you want, you can try. I will take out this. We'll paste it here. If you want to try it. Okay, no, not needed. The same diagram is there, no? So this is applicable when both are same, either hollow or solid sphere, the way what we did, and then the corrections will be done. Let me explain the first basic concept, so they'll be easier. So both are what we assume hollow sphere. Hollow sphere, this is also hollow sphere. Then what all we do, okay, that will be applicable. You can see, no? And anyway, masses are same. I think there's no fun in repeating the same thing. Then the frictions will be same. F1 equal to F2. You calculate that also, you'll end up with same thing. To 5/3. Either you do for anything, the conditions is same. Okay, this will be 5/3. Okay, I get this. So here you check it. F1 is in fact equal to F2, that one. Then what all we do, everything is fine, justified. Okay, first I think a student must have initial diagram. Either you do for any other thing, so you're going to get the same answer. The spring is elongated by x naught and released. Find time period of oscillation. The same question. So we made it very simple. Let it be hollow sphere and both are having same mass. Even masses are different also we can manage. Even masses are different we can manage. The answers will be same. In fact, this M1, M2. So M1 equal to M2. If masses are different also, no problem. The answer will come. Okay, I think till here there's a problem. But the question what is given is not this one. That's why the answer what happened we ended up. Now okay, now it's justified. So what all I did now, you can see that one. So don't think that the procedure is wrong. That's why I just picked up this problem. The idea is same everything. Okay, either you do for this or this, you'll get the same answer. Agreed? No? Yeah. So the method is, don't say method is wrong. So the everything we got same answer. Okay, now after this, you get this particular question. So here there's a one problem is that what is headache? Both are different sphere. The center of mass will in fact shift. So we are going to discuss the SHM about a point where center of mass will accelerate. Okay, I need a lot of time. Okay, that's fine. Tomorrow I'll continue this particular question. If you want, you can try it. I'll keep it in the corner. Okay, I agree with this. So now let me, tomorrow we'll deal with that one. Okay, let me take the one more rolling is there. We'll finish off this.